Welcome to angle side congruence. So here we have two consecutive angles and a side that is not in between them. So we are not talking about angle, side, angle. We are talking about two angles and then a side that is not in between them. All right, so for our first example, I have these two triangles that I'm trying to prove congruent. Triangle ABC and EDC. And that's what I have here that I'm trying to prove it. Let's talk about our given first. So I'm going to do this one first in blue. So my first step I'm doing in blue, it says that AB is parallel to DE. And I know the reason is given because it is right here next to the word given. So AB is parallel, which I actually already made a notation on my diagram, to DE. So those two are parallel. Once you hear parallel lines, you should be thinking about corresponding angles, alternate interior angles, alternate exterior angles, or same side interior. So one of those is going to come into play. For our second step, we have angle BAC is congruent to DEC. And the reason would be alternate interior angles. So just as I mentioned before, I am going to show you this using the highlighter. So we already know that these two are parallel. So then that means that either this line right here is the transversal or the other line. I'm not exactly sure which. So I decided to pick this one for now. And so I went for, I'm going to do this in red, angle BAC, so this one right here, is the same size as DEC. Those are called alternate interior angles, which I'll draw here. So it looks like this. And the reason they're alternate interior is because one is on the bottom of the transversal and one is on the top of the transversal. All right, so now let's keep going. So now we have as our next step the angle ACB. So ACB, so coming back here, is the same size as ECD. ECD. And that was done in purple. And the reason for that is vertical angles. Vertical angles will always help you. So make sure you always identify them. All right, so now we're going to actually talk about the other given that I never talked about. So the second given was right here, CB. So this one right here is the same size as CD. So I did that in this kind of burgundy color. And now you can see why from this step right here, the alternate interior angles, I decided to go for AE as your transversal. And the reason I did is because now you have an angle side. And you can verify that what happened on this triangle also happened on the bottom one. I started with my red angle, I went to the vertical purple angle, and I went to the burgundy side. So I have AAS for both of them. I'm just going to write it one time though, so you don't get confused. So I have that triangle ABC is congruent to EDC by angle side congruence. Okay, so now before I keep going, again, I just want to tell you why I chose the transversal. So I am going to actually erase this. So the reason I chose the transversal to be AE is because if I chose BD, you would have this situation going on. You would have alternate interior angles, you would have vertical angles, and you already have a side. So it would spell AAS, which is perfectly fine for proving these two triangles congruent, but today's lesson is on angle side instead. Here's another example, and remember today's lesson, like I said, is on angle side. So we have angle B is congruent to angle D, and that's actually already written here inside the diagram in red. And we also have another given, AC bisects angle BCD, and we're trying to prove that the top triangle, triangle ABC, is congruent to the bottom triangle ADC. I decided not to start with the given. I actually started with one of the easiest properties. AC is congruent to AC by reflexive. So I am going to do that in blue. So AC is congruent to the top as it's congruent to the bottom. In case this tick mark kind of confuses you, you could put it as an X. Some people do that to show you that if I were to separate these like this, I'm not a good artist, but you can see that that side right there is congruent to itself because you separated them, but they happen to still be the same length since all you did was separate the triangles. Then I went with the given, which I'm going to do in purple. Line AC bisects angle BCD. So line AC, that one right there, bisected BCD. So I didn't even put any kind of a notation for these angles right here, but that's because I am going to do that in my next step. Because once you see the word bisects, there has to be two twins that come out of it, because bisects means cuts in half. And in this case, we had an angle bisector. So now I can safely say that this top triangle, called BCA, is the same size as this bottom angle, sorry about that, DCA. So now we have those two triangles matching because this large triangle was bisected. Don't forget that once you have bisects, you should have two equal parts coming out of it, either a segment or an angle, depending on what was bisected. And the answer will be definition of bisector, in this case, angle bisector. All right, and we're back to the given. The given right here, which I did in red, I will show you again. Angle B is congruent to angle D. And finally, I put what I'm trying to prove right here because I decided that I am done. So it should be at the last step on the left, kind of like your concluding sentence. Triangle ABC, the top triangle, is congruent to triangle ADC, the bottom triangle, by angle side. So just to show you, here's our first angle, the red one. The second angle would be the purple one, and the side would be the reflexive property. Just to show you that matches, this first angle was the red angle, matches. The second angle was the purple angle, matches. And the side AC for the top triangle should be AC for the bottom one, which matches. So if you read it this way, it is angle side. All right, so now we have actually a very long question here. Oh, sorry. Oh, let's see if I can move this. No, I cannot. All right, so let's move it here. So we say the directions are use angle side to prove the triangle is congruent, given that angle A is congruent to angle D. So I'm actually going to pause there and put that information in. I'll put it with green. So angle A is the same size as angle D. Okay, and they also said that angle B is congruent to angle E. Remember to do a different notation because they are not congruent to the first two angles that we said. Okay, so if we're talking about angle, angle, side, we already have one pair of angles that match, a second pair of angles that match. We need a side. Okay, and I know that the answer is definitely not. So look, I'm saying the word not to find BA to see if it matches ED. And the reason that would be incorrect is because if you did it, you would be spelling angle, side, angle, which we do not want to do. So in this case, since they're telling us to do angle, angle, side, you can choose AC and compare it to DF. That's perfectly fine. Or BC and compare it to EF. Those are the only two options you have. So if you see what I wrote here, I decided to go for BC and EF. All right, so now let's talk about what I did. I am going to do the first one in black. We need to check if a non-included side is congruent to the corresponding side in both triangles, just as I mentioned. Let's check if BC, which I highlighted in yellow, is congruent to EF, which I also highlighted in yellow. So we're checking if these two are congruent using the distance formula. So first step, this is what I did in black. I did distance of BC, and just make sure you always label using the coordinate pair correctly. I had negative 5, 5 and negative 1, 2. I chose this one to be x1, y1, and I chose this one to be x2, y2. The distance formula is here. Make sure you're familiar with it. It will never go away. Okay, so next, after doing the math here, remember all your sign rules. And remember to use PEMDAS, doing the inside of the parentheses before squaring it, and then squaring it before adding it. You get 5 units exactly. So then I needed to check that with EF. So EF here, again, just make sure you do label everything correctly, because if you do, then the formula should not give you any problems. I decided to call this x1, y1, x2, y2, and do the distance formula. There's no shortcut to this. You have to do distance formula twice. Again, do the inside of the parentheses first. Remember your sign rules. Then square both sides and then add them. Take the square root. You get 5. So if you notice very carefully here, you get 5. And you also get 5, which means they're congruent. So now I can put this little tick mark for them. So finally, I can say that triangle ABC is congruent to DEF by angle, angle, side. So remember, it was this first angle matching that one. So that's angle, angle, and then the side was not included. So that is what would be considered a difficult problem. If there's any questions, please don't hesitate to ask me through email or Google Classroom. And this template was from SlideSgo.